We will study about congestion control in this video. Okay. Congestion control. So what is congestion control? In this we will try to avoid traffic congestion. Okay. So what is congestion control? That is to avoid traffic congestion. That is when you are sending some messages to the network, if more number of messages are in the network, and basically it is generated by switches or router, and this congestion. So we will try to understand why the congestion happens and what are the remedies that if we follow it or practice it, then there will be no congestion or less congestion in the network. Okay. So in this case, first we will study about the traffic descriptors. So let us study traffic descriptors. So here we will study one diagram. So one, you can say, a graph. Okay. So this is data rate descent, and this trend is nothing but second. Okay. So this is second and this is the data rate, and suppose this goes like this way, it goes, and this one, and finally it goes down. Okay. Now this is the maximum, this is the peak data rate. Okay. So this is this part, the highest part is nothing but peak data rate. Okay. And this part to this part, from here to here, this part is called the maximum burst size. Maximum burst size. Now what is the maximum burst size? So it is the maximum length of the time the traffic is generated at peak rate. Okay. So that is maximum burst sized. I write over here, maximum burst size is nothing but you can say maximum length of time, the traffic is generated, the traffic is generated at peak rate. Okay. And this is the peak rate. And there is also one thing, it is nothing what now, what is the data peak data rate? It is the maximum data rate of traffic. Okay. So it is the maximum data rate of traffic. Okay. Now we will study another thing, that is this is, if this is the maximum peak rate or maximum thing, this is the average. We will study this is average. So this is the average data rate. So this is nothing but average data rate. Okay. So what is the average data rate? Total amount of data divided by total time. So we can write here, average data rate is nothing but it is total amount of data divided by total time. Okay. So this is about the traffic descriptors. In this diagram I have shown it. Okay. And it is important. Next we will study about congestion. Okay. So next we will study about congestion. So what is the congestion? It may occur if the load on the network is greater than the capacity of the network, and it occurs due to queues in the router and switches. Okay. So in the theoretical part we can write that it may occur if the load on the network is greater than the capacity of the network. Okay, it occurs due to queues in router and switches. Okay, so congestion we can write, it is when load is greater than capacity. Okay, so what is load? Number of packets sent to the network. So it is nothing but number of packet sent to network. And what is capacity? Capacity is number of packet a network can handle. So capacity is number of packet a network can handle. So let us draw one diagram. Hopefully you will understand. So suppose I am right, this is your sender. Okay, so this is the sender, 1 2, these are all the data packets. So this is sender, and there is a network. Inside this there is a network. Okay, and this is nothing but another, there is a receiver, 1 2 3, this is receiver. These are the queues. Okay, this is the receiver and queue, this is the sender and queue. And first suppose say that this job came here, next this one came here. The sender is keep on sending and the jobs are deporting over these buffers. Next again it came here, and the sender doesn't stop at this moment. Now sender will again send and data, but since there is no free in the buffer, so it will just make a traffic go on sending. So it is, so these three, okay, there is a buffer and these messages are kept inside the buffer, but remaining messages there is no buffer in the receiver, so this will create the congestion. So this will create the congestion. So this is a pictorial diagram, you can say that how the congestion is created. Okay, and in this thing we will try to introduce another thing that is called throughput. So what is the throughput? Throughput is a function of load. Okay, so you have to remember that throughput is a function of load. Okay, next we will study the two things, that is the network performance and see what are the network performance is. Okay, so for that we will have to draw one diagram. So let us first draw the diagram. Yeah, that's fine. So let us draw the diagram first. So okay, another thing we have to study, that is what is the effective bandwidth. So effective bandwidth. So what is the effective bandwidth? The bandwidth that a network needs to allocate for traffic flow. So bandwidth that network needs to allocate for traffic flow. Okay, so this is the effective bandwidth. Next we will study about network performance. Network performance. So we will draw this with a diagram. So this part is delay, okay, and this is load. Okay, now we will do one thing. We will describe one thing, that is called the capacity, maximum capacity. This is the capacity, load, and this is the capacity, and this is the maximum capacity. So initially what will happen, it will go like this, but after that the capacity is reached, that is you are going increasing the load and delay is also increasing, but when it reaches the maximum capacity of the network, the delay will just, it will go high like this way. Okay, so this part, this line is called, this is called infinite delay. Infinite delay. Okay, and there are two things that is we have to discuss. That one part is over here, this part, and this is the part. So this part, this particular part is called congestion free, because basically there is no congestion. So congestion free part, and this part is called congestion area. Congestion area. So this is congestion free part and this is congestion area. Okay, so what is this thing? So it is delay as a function of load. So we have drawn this particular thing. Now another pictorial diagram we will try to describe. So okay, let us draw it. Yeah, so this one we will draw like this way. Again, this is the capacity. Okay, this line is capacity, this is load, and this is throughput. We will now draw the throughput as a function. So caption is throughput as a function of load. So this is the delay as function of a load, and this is throughput as function of load. So this is a throughput, this part is throughput. Okay, so what is the throughput? Number of packet passing through the network per unit of time. So throughput means number of packet passing through the network per unit time. So throughput means number of packet passing through the network per unit time. So you can understand what is the throughput now. So here also the graph will be like this. First it will go this way, throughput will going increasing, but after the maximum capacity is reached, this will just eventually it will fall down. Okay, so this part is called congestion free and this part is called congestion area. Okay, so this is congestion area. Okay, so this is the throughput as function of load. I have drawn over here. Another thing we can draw, that is the data rate versus time. Okay, so there are three types of data rate. That next we will draw. Basically this comes on the traffic profile. So let us study about the traffic profiles. Okay, so what is the traffic profiles? There are three things we will have to study. That is burst data, that is, and CBR, and that is constant bit rate, and VBR, that is data flow changes with time. Okay, that is variable bit rate. So let us draw these three pictorial diagram. So again I am drawing this one. Okay, so constant bit rate is this one. That is, okay, this is time and this is your data rate. This is time and this is data rate. So this is the constant bit time, so constant bit rate. Okay, so CBR. So what is CBR? No change in data rate. Okay, no change in data rate. So traffic profiles, first we have studied about constant bit rate. So CBR means constant bit rate. Constant bit rate. Next VBR. VBR will go like this way. Okay, so this is nothing but VBR. So what is VBR? Data flow variable bit rate, that is data flow changes with time. see there is a change, so data flow changes with time. So this is a VVR. And another thing is that bursty data, that from it will go to the peak, from peak accidental suddenly it falls down. So this is bursty data. Bursty data. So what is the bursty data? That data rate change suddenly. Data rate change suddenly. Okay, so this is the bursty data. So these three diagram you have to remember about the network performance. There's delay as a function of the load. Next is throughput as a function. This is the delay as a function of the load, throughput as a function of the load, and this one is traffic profiles. So this is the data rate, and this is the time. This is the bursty data, that it will fall suddenly. Constant bit rate, it will go on constant like this way, that no change in data rate, and this is variable data rate. Okay, so these three things. Next we will study about the congestion control. What are the categories of this congestion control? Okay, so next categories of congestion control. Fine. So we'll study about congestion control categories. So just one. Okay. Congestion control categories. Okay, so congestion control categories. So it has been divided into two parts. One is open loop. Okay, so it is basically two parts. One is open loop and another is obviously closed loop. Okay, so open loop is used for prevention, and closed loop is used for remove that particular part. Okay, so let us study about open loop. First, about open loop. Okay, so open loop is for nothing but prevention. So there are, first we will study about retransmission policy. There are basically 5 parts in it. So first we will study about retransmission policy. Okay, so retransmission policy is nothing but this is a sender, this is a receiver, and it will send some data from here, and if go on sending data from sender to receiver. So this is a retransmission, and it falls in the TCP. Okay, so it falls in the TCP part. So first open loop retransmission policy is there. Next is window policy. Okay, window policy. So what are the window policy here? So selective repeat ARQ is the better. So in case of window policy, selective repeat ARQ is better. So they use selective repeat ARQ for the open loop. And next is acknowledgement policy. So what is the acknowledgement policy? Well, receiver will send acknowledgement after time and or after in packets. So receiver will send acknowledgement. Why this is sent after certain time? Just to avoid the congestion. Okay, so receiver will send the acknowledgement after a time, not every time, not for each time the data is received, but after certain time, so that because this acknowledgement also create the traffic. So if you send the acknowledgement after certain time, so it will not create that amount of traffic. Okay, so receiver will send the acknowledgement after a time, okay, or after in packets. So if it send for each and every packet, so for each and every packet there will be each acknowledgement. But if you send for after n packets, suppose 10, then for 10 packets you send only one packet. So obviously you can understand that if you send less amount of acknowledgement, but still you can work fine, then it is better go for the after send the acknowledgement after some time or after n packets. Okay, so it will just decrease the congestion control in the network. Okay. Next part is discarding policy. Okay, discarding policy. So what is discarding policy? That is the discard less sensitive packets. So discard less sensitive packets. Okay. So 4 and number 5 is final is admission policy. Admission policy. So what is admission policy? Just resources checked first time before admitting to the network. So resources are checked first before admitting to the network. So since you are checking these resources before admitting, so it takes some amount of time. So in the network before admitting, if you take some amount of time to place those resources in the network, so in that cases the network congestion will not occur. Okay, because randomly you are not admitting all the packets frequently, because you are checking it and then you are either you are discarding it, or if you find okay it is good for you can send, there is no problem in the packet, then you can send in the packet. So it will take some amounts of time, and ultimately it results in the less congestion. Okay, so this is about the open loop policy. Next we will study about the closed loop policy, and it also consists of not 4 parts, but it consists of only so open loop consists of 5, but closed loop consists of only 4 parts. Okay, so let us study now closed loop. Okay, so it is nothing but it is removed, and so first one is back pressure. So back pressure, so suppose this is a sender and it is sending some information via node n1, then node n2. Now suppose this is n3 and some problem has arisen, congested. This is the congested node, this is n4, and this is maybe your n5, and this is your destination. So some problem is arrives over here. Okay, so basically you intend to send a packet via this line, okay, to B, but due to the congested node, this node has become congested, so it will do what? It will send a back pressure to n2, then it will go to n1, and finally it reaches to the source. So this pressure will be created over the opposite direction, and what will happen? Finally the sender will stop the sending messages. Okay, so this is called the back pressure. Same thing, but to some extent different, that is called choke packet. Choke packet, it is same as more or less same as this, but there is one difference. So let us see what is the difference. So in this case, suppose this is a sender and you are sending this node, sending the message to n1, then some node n2, now this is n3, and this is going like this way, but due to some congested node, this is the congested node, so this is also congested node, and this is also congested node. Okay, so due to some congestion over here, it will send a choke packet. So it will send some choke packet. So it will send some choke packet to the source. Okay, so it will send some choke packet to the source. Okay, so it will not send those packets via n2, n1 and s1, but directly it will send to the s1. Okay, avoiding these two nodes. Okay, so this is the choke packet. In case of back pressure, this message will send via n2, n1, s, but in case of choke packet, it will send directly to the source. Okay, so this is the second one. Next part we will study about implicit signaling. Implicit signaling. So what is implicit signaling? So no communication between congested node with other node or source. Source assume that congestion occurred, and it has two types, that is acknowledgement not received and delaying acknowledgement. Okay. So for implicit signaling we can say that no congestion between no communication between congested node with other node or source. Okay. Source assume that congestion occurred. Okay. So that is basically of two types. One is acknowledgement not received, and another is delay in acknowledgement. So by this we can understand that congestion has occurred. Now this is implicit signaling, and finally we will study about explicit signaling. Explicit signaling. Okay. So congested node, here the congested node sends a signal to source or destination that signal is included in data packets. Okay. So it is also divided into two parts, that is backward, there is node to source, and forward, that is node to destination. So for the closed loop we have studied the four parts. One is back pressure, choke packet, implicit signaling and explicit signaling, and we have discussed all the things. So what we have studied till now in the congestion control, that what is the congestion control? That is we try to avoid the traffic congestion. Then we study about traffic descriptors and see the diagram. Then we study about the congestion. What do we mean by congestion? In that case, there's always load is greater than the capacity and the congestion has arrived. And if this condition holds, that is load is greater than the capacity, then congestion happens. Next we study that what is the effective bandwidth. Next we study about network performance, that is delay as a function of load. Again we have studied another plot, that is throughput as function of load. Next we study about traffic profiles, that is constant bit rate, variable bit rate, bursty data, and finally we have studied about congestion control categories. It is categorized into two parts, that is open loop and closed loop. In open loop is for prevention. It has 5 parts, that is retransmission policy, window policy, acknowledgement policy, discarding policy, and admission policy. And in case of closed loop, 4 parts is there, that is back pressure, choke packet, implicit signaling, and explicit signaling. Okay. So all these things we have studied in the congestion control. In the next video we will study about quality of service. Okay. So in the next video we will study about the quality of service. So what is the quality of service? It is that is we try to create an appropriate environment for the traffic so that traffic and less congestion is there. So we will study that quality of service, that is QoS. in the next video. Okay, thank you.